Hi, my name is Z, and today I'm going to talk about Nix and NixOS. This is my favorite Linux distribution, and it's one of my favorite tools for building software. However, it has a lot of rough edges that make it hard to learn and make it just not as perfect as it could be. In this talk, I'm going to go over a lot of what makes it great and what I'd love to see make it even better. As I said, my name is Z. I write a lot about Nix and NixOS and use it a lot personally and soon professionally. As a disclaimer, this presentation may contain opinions. These opinions are my own and not necessarily the opinion of my employer. I do not intend ill will to any people or their work in this presentation, and I want this to be better because I am passionate about these tools, and I believe that this is the best and obvious choice to do things. The QR code on the slide links to my website, christine.website. I'll have the talk of on the website within the same day of the presentation you're watching right now. Let's start with why NixOS is great. NixOS is great because it lets you pick from cookie cutter templates to make a server do exactly what you want. It builds on the shoulders of giants to make it easy and effective to make your servers built to purpose. As an example, here's a little NixOS module that enables Nginx and Postgres on a server. That's it. This modularity also extends to your own custom modules. I've done some write-ups on how to write these custom modules, but here's an example for one. It's my Gemini server. Finally, one of the best parts of NixOS is that it makes it hard to do something the wrong way. You can't just hack up a systemd unit on the fly. You need to do it the right way in configuration management. This makes it easier for you to ensure servers aren't being tampered with without going through a review process, and so you can go back to a project in 6 months and still have some idea on how it's supposed to run on a computer. However, one of the biggest things in my book is the fact that NixOS lets you undo configuration changes. Worst case, you might need to reboot into an older config, but in general, if you mess something up, you can go back. This is a lifesaver, especially when you mess up network configuration. So this sounds great and all, but you might be thinking, there's a catch, right? There is a catch. It is hard to learn. The tooling and documentation are not the best, and they are the most important parts of the stack that you deal with when you're learning it. This is a little comic showing a rocket-powered wagon, which is kind of what NixOS can feel like at times. One of the bigger tooling issues is somewhat technical, somewhat social. Right now, the Nix universe is in the middle of switching to a new hermetic view of the world they call flakes. Flakes has a lot of differences between classic Nix, and it makes a lot of techniques and configuration non-transferable between the two. It has effectively soft split the community between people that use flakes and people that don't use flakes. I personally don't use flakes because I haven't seen good arguments as for why I should. Nix, the language, can look a bit like a combination of Haskell and Bash in ways that are kind of deceiving to people that don't have solid experience with Haskell or other functional programming languages. This is a little bit of code that breaks a host : port thing into just the port number so that you can add it to a firewall rule. Additionally, it also checks if you have TLS enabled with HTTP certification for Let's Encrypt and adds port 80 for that. But if you aren't really familiar with Haskell or other functional languages and without the 14 plus lines of comments explaining what's going on from the place I pulled this from, it's going to be difficult to understand what's going on. Another annoying part is that Nix, the package manager, Nix, the language, and NixOS, the operating system, all have very similar names and kind of semantically override. I have created a handy diagram with a bunch of that maps out the relationships between them, and here it is. Nix, the language, is not Nix, the package manager, though Nix, the package manager, uses Nix, the language, in order to do things. Nix, the OS, is not Nix, the package manager, even though it uses Nix, the package manager, to manage packages. And NixOS, the OS, is not Nix the language, even though NixOS uses Nix to configure itself. The overall relationship is similar to the Holy Trinity or JavaScript equality rules and can be a bit deceiving to learn at first. Another paper cut is that Nix does have a REPL so that you can hack up things quickly and so you can get to learn the language a bit better. However, the REPL can take different syntax than you can put in files. So if I want to declare a variable like foo equals bar and then use it somewhere, in the REPL I have to do foo equals bar without a semicolon or without a let. That can be very annoying at first, because you can hack up something in a REPL and then your instinct is to go and paste it into a file, but you need to edit it a little bit, and it's not entirely obvious at first. NixOS has modules to configure itself. However, these modules are only as flexible as they are written to be. If someone doesn't allow you to do a certain type of configuration to a program that's behind a NixOS module, you just can't do it without fixing the module. These sort of make them more like templates instead of functions for reaching a desired system state. However, this will get you most of the way there, but when you get into very complicated setups, it can get challenging. Adding on to this, most of the modules in the standard set that are shipped with NixOS are not documented in the NixOS module, including Nginx. There's a search site that lets you query the list of options in the standard set. However, if you're not entirely sure what you're doing, there's not always a good template to start from. When your needs change beyond what the NixOS module is doing, you can actually monkey patch it. However, you have to monkey patch the side effects of the modules rather than monkey patching the module itself. As an example of an obscure module, let's look at WeChat here. WeChat is an IRC client, it's the one I use, and NixOS has the ability to manage WeChat for you. This is all of the documentation for the WeChat module. All of these things expand out and have more detail, but these are all of the settings that you have directly. Another thing about this module is that it's great for running one instance of WeChat, but if you want to run multiple copies of it for like a community shell box, you either need to write your own NixOS module that allows you to do that, or use NixOS containers to do that, and at that point, why not use Docker? Another huge paper cut is with disclosure and vulnerability detection for security reasons. Something important for both standard production and certification is the ability to answer the question, how do I know a server is patched against a certain vulnerability? There are a lot of inherent advantages to Nix and NixOS that would make this a lot easier. However, there is not really a good way to do it, and there are not regular communications about security vulnerabilities. This can make certification difficult. Another annoying thing is backports. There are no hard rules on what is to be backported and what is not to be backported, which means that packages in stable branches likely will bit rot from what the upstream intended they would be. Most of the time, you can run NixOS unstable to work around this, but it may not be the best idea to run the unstable branch in production. Also, if you want to configure PAM to do something special, such as send a Slack message to some channel whenever someone logs into a machine or runs a sudo command, and that option is not already in the PAM options in Nix packages, you're basically doomed, because PAM is not very configurable on NixOS. The PAM modules offer you the ability to enable things like TOTP, two-factor auth, but that's about it. Another annoyance comes when you're trying to deploy software on a production cluster using Nix itself. There's not really a good tool in the standard Nix toolset for this, but there are tools like Nixops and Morph, and these allow you to describe the state of your entire fleet of computers with the same NixOS module syntax that you use for local machines. However, the documentation for these is lacking. Nixops does have a fairly decent manual, and the documentation for Morph is a bunch of example configuration files. I have a little screenshot of part of my Morph configuration for my home lab. This manages the NixOS machine under my desk. There are other options using NixOS and Morph, however, these are the more Nix native approaches to do it. Because NixOps and Morph aren't very documented, it makes it an annoying catch-22 situation where learning NixOps and Morph requires you to already know how NixOps and Morph work, which can make it hard to get started from scratch. This is part of the reason why I make all of my NixOS configs public on GitHub, so that people have something to go off of when they're trying to figure out how to do more complicated things. Without publishing my configs on GitHub, I would be afraid that people would get incredibly lost like I was when I was trying to figure it all out. As an example of things that just got me totally lost, let's talk about keys. NixOps and Morph use the term key where other ecosystems would use the term secret. They basically allow you to have values that aren't managed in your Git repo for things like database credentials, AWS credentials, or other API keys. And normally you want to have things so that this service, for example, a service that I wrote for myself called me, depends on the keys for it being started. In NixOps and Morph, what you're supposed to do is you're supposed to make a secret for that. It will create a systemd service, and then you sequence the systemd job to start after the key. However, the documentation doesn't really make it clear on how to do this, and I had to figure this out by searching GitHub for NixOS code, praying someone already figured it out and made it open source. Another annoyance is that you can't pull values from other machines in your cluster. If you have a VPN with a dynamic IP address and you want to pull that IP address to use in various bits of configuration, you're going to have to hard code it somewhere, which means that it's a bit more difficult to do things dynamically. In comparison, when using something like Ansible, it is trivial to pull this information off of a machine with its fact system. Finally, let's talk about what I think could make all of this better, easier to learn, and a much more obvious choice for production. These are my ideas. They may not entirely work in the real world, but in an ideal world, this is what I'd love to see. First of all is I would love to see the documentation being the strongest part of the NixOS ecosystem. Documentation is the difference between understanding something and not understanding something. You generally have to understand something to be able to use it productively. In general, the standard documentation should cover how to get started, what you can do, and detailed documentation on every single thing that ships with NixOS by default. There should be no module in the library of modules without documentation on how to use it and an example or two of where you'd use some of the weirder options. Error messages are also critical for understanding what's going on. Here is an example of an error message that I have encountered in Nix and NixOS a lot of times that just has utterly baffled me every time. No, adding the show trace flag does not show more detailed location information. In this case, I got it by sequencing a package import in the wrong place in a way that didn't seem obvious to me, but without better error messages, you just have no idea what's going on. Let's consider some examples of better error messages I've seen around in other projects. Here's Rust in Elm. In this case, Rust is saying that I don't know what you're doing with this value. You're trying to return something from an if statement, but then you're just totally ignoring it. And in Elm, list.nap is used in place of list.map. In both of them, the compiler tries to work with you to help you figure out what went wrong. Another great thing about what Rust does is that it has error codes that you can Google for when you have something going wrong, so that you can more easily understand what you're doing wrong and how to learn how to not do it wrong in the future. This is being worked on. Here's an example of what the better error messages look like. I just wish this was here sooner. Another way that things could get a lot better is by taking advantage of language-specific package managers to automatically figure out what to do instead of having to fight them against what they are doing. There are tools that automate this, but ideally I'd like to see this just automatically happen using import from derivation or something like that. As it is right now, packaging things like Go, Node, and other things are really iterative and annoyingly non-trivial. Maybe it would be better to have modules act kind of more like functions than templates. It would be nice to have modules return something that you can splice into your configuration instead of the modules being enabling something into your configuration, so that you can manually monkey patch things and run multiple instances of a service if you wanted to. You can work around this, like I mentioned, but it would be better if this was a native solution. And that about wraps it up. NixOS is actually pretty great. It's just really frustrating to get started with. I really wish it was easier, but right now it just isn't. If you have any questions about this talk, please feel free to ping me on Twitter or on the contact or some contact method on my website. I love answering these questions. I'll stick around in the chat for a bit and answer questions if you want to ask them there. Thank you. Stay safe and be well.
Okay, thanks. I'm going to add Z to the stream, and I think we have time for a couple questions live. So here we go. Here's Z. Are you there, Z?
Yep, I'm here.
Okay, awesome. So I guess, let's see. I think you've already answered some of these in the chat. I had one on importing language-specific package manager packages. A lot of those do dependency resolution with a solver. Are there challenges to integrating something that does that into Nix, which basically has humans as the solver managing the repo?
Actually, I have kind of a hot take opinion here, but I think that we should just take the output of the Nix out of the language-specific package manager solver and import that into Nix, because if you don't do that, then things are going to get very confusing for like the upstream maintainers when they're trying to find a bug, because they would expect the one solver that npm or Go uses to be the thing that is actually shipped.
Sure. Okay, I like that take, actually. I think that's cool. That's like importing a lock file version of something.
Yeah, that's what the import from derivation stuff I mentioned was. In the case of like Rust stuff, it'll literally walk over the cargo.lock and turn it into a bunch of Nix instructions to grab the things that Rust concluded was the right thing to do.
What about when the ecosystem solver doesn't manage certain things in, say, the Nix ecosystem, like lower level libraries and stuff like that?
That's going to be a problem no matter what you do, but you can get pretty darn close. And most of the time when those language-specific package managers can't find a native dependency, they will explode loud and angrily. And usually yes, the explosion has enough detail to go off of.
Okay, cool. I'm not seeing too many other questions in the chat. I guess, do you want to do this one live? Did you try to improve the lacking documentation? What was the blocking point you faced during the process? Any comments you want to say live on that one?
Apparently at the time when I tried to improve the documentation, it was all in DocBook, and I am apparently quite terrible at editing DocBook, but now it's Markdown, so I can probably do it a bit better.
Awesome. What is your take on secrets or things that you don't want in the store? From Fareed.
That is actually a surprisingly complicated topic. I thought it would be easy, just like make sure that the files get there somehow. But then comes the bootstrapping problem of if you just put the files in like /run, like NixOps wants to do, then when you reboot, the entire system is stalled waiting for the secrets to be manually deployed. I think the ultimate solution is probably something like the AWS buzzword or HashiCorp Vault. But it's a surprisingly complicated problem. I personally get around it for my stuff by using Age to encrypt things for the machine's SSH host key. And then I will have a bunch of systemd jobs decrypt things and put things in the right places so that the decrypted configuration file is there before the encrypted configuration file is there before the underlying job starts.
Okay. All right. Well, I think we should get back on schedule. Thanks for having a slightly shorter talk to allow us to do that. And I thought that was a really great talk.